Welcome to the video. In today's video, we are going to discuss about respiratory pathway, that is the amphibolic pathway. So, the amphibolic pathway is the one which involve both anabolism and catabolism. That simply means that in an amphibolic pathway, we will see anabolism as well as catabolism of molecule. Now, for this, the best classical example that we can consider is of Krebs cycle. Krebs cycle is a classical example of amphibolic pathway. That in Krebs cycle we will see the catabolism of carbohydrate and fatty acid and anabolism of amino acid. That is why Krebs cycle is a amphibolic pathway, because here you will see the catabolism of carbohydrate and fatty acid as well as the anabolism of amino acids. Now, how will it occur? Okay, so the fat will be broken down into glycerol and fatty acid. Okay, if fatty acid were to be respired, they would first be degraded to acetyl coenzyme and enter the pathway after being converted to PGAL. Now, the next important thing is that glycerol will enter the pathway after it is converted to PGAL, because a fatty acid can easily be catabolized into fatty acid and glycerol. Here you will see is that the fatty acid will move to become what? Acetyl coenzyme A. Here you will see that the glycerol will become what? Glyceraldehyde 3-phosphate. Whenever the body has to synthesize fatty acid, this acetyl coenzyme A will withdraw from the pathway and anabolize to become fatty acid. The proteins are degraded into individual amino acid, and these amino acid will go in different stages of Krebs cycle. Here we have seen that how respiratory pathway has used catabolism and anabolism both. That is why respiratory pathway is known as amphibolic pathway. Thank you so much for watching this video.